Right. I thought I'd better do an update on the situation at the moment. I now have all my generator coils basically the same. There's 700 turns of 30 SWG wire on each bobbin. I had a bit of a mishap earlier today. I went and tried to pull one of my bobbins out. Bad thing to do, because I went to split the thing in half. Well, good thing about acetone when it comes to ABS is you can stick it back together again. So I actually repaired it. This is the one I broke, but I fixed it again, so I've got a spare one now. Luckily I had enough 3D filament, just barely enough 3D filament to print another bobbin out, which is what I used. I'll just explain situation at the moment. The toroids that I've wound with steel shims, which are these things. All they work a certain degree. The main problem I'm finding is that they aren't in resonance. They're still not the right resonant frequency for my device, because my actual device is if you measure the frequency on the let's do that actually. Let's measure the frequency and I'll give you a rough idea what's going on with this. Just let me get my meter connected up. Right, if I stick it on frequency, and we'll connect it up to, oh, hang on a minute, just a sec, I need my clips. Stick my clips on. I went and broke my lead earlier. I had to repair it. That's a lot of use it gets. Right, so if I clip this onto, doesn't matter what I clip onto really, let's just, actually I can clip onto this end here, comes out of the, I've got this lead clipped on here, so, let's just see, oops, they don't want to stay on, doesn't matter what I clip onto, let's see if I can clip onto some, a bit easier. Oh yeah, I can clip onto my capacitors at the back, that'll be easier. Doesn't matter where I clip it onto, the frequencies obviously are all the same on each channel. Right, okay, so frequency that we have on each channel is basically 242 hertz. Right, well that's because of the there's obviously 4 axis on the generator magnet, so it might actually rotate at about at 1/4 that speed. So if we divide 242 by 4, we basically get the RPM frequencies, whatever. Anyway, so it's 0.241 kilohertz, which is basically 241 hertz. Yeah. So what I need to do is in the next month or so, because I'm going to get a little bit of money, I've got to get my fridge sorted out, as I was mentioning previously. So what I plan on doing, oh look how that changed just by putting my meter on there. Look at that. See how the LEDs flicker rate changed just by putting my meter on it. Wow, that's quite a difference. Actually, does that make any difference to the RPM? That's weird, that. Speed, I'm looking at RPM over there. Right, we're at 4156. Let's climbing actually, let's take it off. It's actually dropping when I take my meter off, that's really bizarre. Speed is actually, oh, it's gone back up again now. Maybe it's not making all that difference. Anyway, I found out something very interesting about my generator. It is, apart from it being magnetic, with the rotors, it attracts spiders. Ugh. Do you remember the other day I was running my generator and a flipping spider ran across the carpet and I kind of yelped a little bit? Well, that same spider turned up again while I was running my generator for 2 hours. It's been running for 2 hours now. And the damn thing was running across this flipping... You can see a bit of it there actually. I squished the damn thing because I was like, ah, not again, not again. Every time I turn my generator on, this spider turns up. It must like the vibration, it must be thinking there's a fly or something, I don't know. Anyway, I squished the damn thing because I don't want it in my bed. So what I was going to explain is at some point, these little transformers, they work quite well, but they don't do enough. They're not in resonance with the circuit, so I am planning on getting some small miniature, what do you call it, transformers, the ones that you get inside old power supplies, you know, the conventional old standard transformer with the E laminations. I was going to wind those great big massive laminations that I got out of that microwave transformer, but to be honest with you, those things are too big. I mean, they're way too big. I was thinking about, well, if I wind wire on those, the inductance is just going to be too huge. It's going to be, the frequency is going to be much too low. So I'll be going from something that's basically too high a frequency to something that's too low a frequency. I really need something that's smaller that I can easily tune more effectively, like a small well, basically like let's see, like this transformer that's in this box. So I really want, yeah, something like that. I need to get 4 of these, right? By having 4 of these little mini transformers, it will be a lot easier for me to tune them to the frequency that I need for this, because I mean this particular one is really tuned for 50 Hertz, but I want something that will work at 4 times that frequency. Why do I leave it in the box? It's just so I don't get it all oxidized and corroded, because it was a new transformer. I just basically borrowed it to do some testing with. But this isn't tuned right either, so at the moment we aren't really getting that acceleration. We're not getting that acceleration when it's under load, because I'm using my analog meter at the moment. We're on the 500 milliamp range, which is the 50, where it says 50. I'm using my analog meter, so about, it looks like we're about 60 milliamps at the moment. Let's see. Yeah. The reason I decided to start using my analog meter to measure the current is because I kept running batteries down. My digital multimeters, that's the only problem with them. You leave them on and they run your battery down. So I decided to use the analog. Besides, I like the analog because I can switch it off easily. I can just flick this switch, turn it off. You see it's off now, look. I can just turn the current meter on to 10 amp range and it switches it off. Turn it back on. Yeah, it's a lot less fighting about when I'm doing my testing. Let's turn it off, let it pick up some speed. So yeah, I am fine tuning everything at the moment. As you can see, I've got my bridge rectifier circuit board underneath there. Get the light on it. So rectifier circuit is underneath there. My output control board is on the top, and I've been adjusting my coils, and I took out all the concentric magnet arrays, which are all here. There's 4, 5, 6, 7. There's 8 of them. So I took out all the concentrics that were on the front end. I've still got them on the back end, which is on this side, because I was losing too much. I was losing too much power, By doing that, the circuit works better. Now let's turn this back on again. What's the current? It went to over 120 milliamps then. But yeah, so anyway, I've still got a lot of tuning to do to get this to work the way I want it to do. Interesting waveforms coming out of those lights. they do look kind of cool though, don't they? You know. So yeah. So a little update. Nothing much to show right now. Current wise, I'm not getting as much current as I was originally. There's obviously sometimes when you make progress, sometimes you take a few steps back and then you got to make take a step back, I should say, to make a few steps forward. It's just about finding out what works the best, and I've observed some really strange anomalies actually with this thing. It's really weird. I mean, I could literally take one leg of one of my coils out, and I think I've got feedback through the rectifier circuit, because it shouldn't technically work with just one wire from one coil going in. But it's weird that it does. I don't see how, because it's AC and you need both legs of these wires in. But when I connect one leg of one of the wires from the coil, it makes a circuit, and I'm thinking, how the hell can it be doing that? But then I'm thinking, well, maybe it's because it's running through one of the coils through to the bridge rectifier, and it's creating a circuit to the other. Yeah, so it's complicated, but that's what's happening anyway. Figured it out because I couldn't understand why when I took one of the wires out the LEDs were still lit, and I thought, well, they shouldn't be lit because both the legs are only one leg's connected. It shouldn't, but it can do because it's running through the triac circuit and it's back feeding into the other coil, which is also connected to the bridge rectifier on the other side, so it's making a circuit that way. Anyway, it's really, you get some really peculiar things going on with this thing, I tell you, when you're tuning it. Kind of does my head in a bit actually. So anyway, what else is there to tell you? Yeah, it's running a lot quieter. I've got rid of a lot of them rattles and creaks and groans that I was getting before. I actually cut the feedback loop circuit that was on my board, that went from the output of this end all the way back to the start of this one. If you looked at the previous circuit diagram, I don't know if I've got it lying around here actually. Here it is. Right, the leg goes, you can't see it, but the legs go from this side to the next stage. Well, I've trimmed some of the legs off so it didn't feed back all the way back to the beginning again, because I wanted to see what would happen. And needless to say, it was right to begin with, and by cutting the legs it made it worse. That's why I've put jumpers on here now to put the legs back on. I'm going to have to solder them later. So my board was right to begin with. I just wanted to test it without that. It's basically doing the same thing as when I switch these coils out with the switches at the back there. So when I switch them out, I can do them manually. But what else is there? Nothing really. I think I've just got to, yeah, I've got other things to deal with. I've got my microwave, my fridge to sort out. I'm going to be ordering some more bits in a few weeks. I've got to get some more filament. What else? Yeah, I think that's about it really. I'm going to disappear before I start going round in circles. Yeah. Anyway, right, thanks for watching.